Okay, so I gotta sketch my graph, so I have to give the domain, range, and the asymptotes of the graph. So first thing I know with this, my asymptote has to be what's inside because it's a vertical asymptote. So I got x plus 1 is equal to 0. So if I solve for x, I get x is equal to a negative 1. So I'm going to come in and I'm going to draw that in right there. Next thing, my range on every single log is going to be all real values. So then my domain has x and a negative 1. So I'm going to go graph this in a graphing calculator. Here's the thing, I'm already in the y equals. You're going to hit math and you're going to arrow up to get to this log base thing. I have a log base 4 and I go x plus 1. So log base allows me to put that in exactly how I have it, so I'm going to hit graph. So right there I have that situation. This is the thing, that goes all the way down. I look for 2 points to plot. I look here, I get 0, 0, and 3, 1. So I come over here and I plot 0, 0, 3, 1. I now come up and I go like this. Looks like a really good graph. So now I think to myself, x and a negative 1. If I come here at a negative 1, is negative 1 the biggest value? Well, I can see very clearly that it's not because 0 is bigger than a negative 1, so I have to eat the bigger of the two things, so I have to eat the x. Okay. So this is the log graphed in Desmos, and I just want you guys to see that. Look at it. So our graphing calculator shows that it stops right there, but when I'm in Desmos, it's showing it that it goes all the way down that vertical asymptote, which is exactly what we want our graphs. The next graph that we have this. So I'm going to get my asymptote, so I can set what's inside equal to 0 and solve, or I can realize that it's going to be the lies inside of lies. It's going to give me a 2. I know my range is going to be all reals. And then I know my domain is going to be x and the value of 2, so I'm coming over here, plotting stuff. Okay, you guys, I'm going to go to a graphing calculator to get myself some things. So I'm going to plug in 1/3. So here we are, math, arrow it up, get my log base, type in 1 divided by 3. Then I get x minus 2, and then I have a plus 2 on the outside. So here's my graph. Ooh, it's going to come all the way along that. Looks like it's going through some nice points there for us. So I'm going to look. I get a 3, 2, and I get a 5, 1. So I'm going to come plot those. 3, 2, 5, 1. The graph is coming along that exponential, and we're going here. So I'm going to come over here and do this. X and 2. So if I come here, 2. Is 2 my biggest x value? If I look, I have all these values on this side, so 2 is not the biggest, so I have to eat my x. Last graph, this one's a little bit more complicated. So first thing I know, domain is going to be all reals. My asymptote, you have that 4x plus 8 is equal to 0. So I need to actually go solve that. So I get 4x is equal to a negative 8, divide both sides by a 4, and so I get x is equal to a negative 2. So that's my asymptote. So then I have x and a negative 2. So I'm going to come and I'm going to draw that in. So then this is the thing. Do I put in like the x plus 2 there? No. I want to put in my calculator exactly what I have there. 2 log base 5 of 4x plus 8 plus 3. 2 math. Arrow it up. Log base 4x plus 8. I add 3, and I'm trying to remember my log. It's a log of 5. Okay, it's in. I'm going to graph it. So this is how it looks graphed. I need to go get some points. So I'm going to go second table when it's done graphing to get some points. Here's the thing. None of my points are whole numbers. So I'm doing this example to show me how I graph just decimals. So I'm going to do a negative 1 and 4.7. So I'm coming over here. Here's negative 1, here's 4, here's 5, 4.7's right there. Looks good. Coming back to my table. I'm probably going to do 4 because 4 looks nice and it's 6.9. I know 6.9 is really close to 7. So I'm come over here. 4, here's 6, here's 7. It's really close. So my graph looks something like that. I still have 2 points of precision and they look fantastic.